Welcome once again to this YouTube channel. Thank you for subscribing. We want to encourage you to continue to share this channel so that your friends can also benefit from videos like this. In this video, we are going to be solving the Cambridge IGCSE Chemistry Paper 4, May, June 2023, and the variant is 41. So kindly pay attention and learn from the video. So let's begin with the first question there. It's of course it has some symbol equations and word equations A to J. We are expected to use this information to give answers to the questions below. So the first one says which of them is a neutralization reaction. So if you can recall that a neutralization reaction is a reaction between an acid plus a base or an alkali to give salt and water. So this is what occurs in a neutralization reaction. Okay, so what happens is that the acid donates a proton, okay, and then the base or the alkali receives the proton that is donated. Of course, they contain the hydroxide ion, and then it forms water. So this is a neutralization ionic equation for a neutralization reaction. So by the time we look at everything involved here, we see that B is the correct answer to this question. So all we need to do is to just write B here. Okay, so the next question says, which of them is a precipitation reaction? Now, a precipitation reaction is a reaction that results in the formation of a precipitate. And a precipitate is simply a substance that is insoluble. So if you look at all the reactions here, you see that the ion 3 and the hydroxide to form this reddish brown precipitate is a precipitation reaction. So in this case, all we need to do is to write A. Now, the next one says which of them results in the formation of an ester. Now, an ester is simply formed when an alkanoic acid or an ethanoic acid reacts or is combined with an alkanol or alcohols. So it forms an ester and it also forms water. So that's the knowledge of organic chemistry. So if you look at all the equations that are given, this is a carboxylic acid example, which is also known as alkanoic, reacting with the alcohol group or the alkanol group to form the ester and water. So in this case, all we need to write is H. Now the next question talks about photosynthesis. So remember that photosynthesis is simply the process by which green plants manufacture their food in the presence of sunlight and chlorophyll. Okay, so this, recall from chemistry of the environment that this is the equation for photosynthesis. So this is very easy. So all we need to do is to write J in this case. And then the last one, okay, before the last one is one that requires a fermentation. So when we look at fermentation, we see that it is the process by which glucose breaks down in the presence of yeast to produce alcohol and carbon dioxide. So this is from the knowledge of organic chemistry, the process of fermentation. So G is the answer to this. And then the final one there is cracking. So cracking is simply the process by which a larger hydrocarbon is broken down into smaller hydrocarbons. And remember that hydrocarbons are simply compounds that contain carbon and hydrogen atoms only. So if you look at all the options that we are given, we see that this D has carbon and hydrogen atoms only. And we can see that a larger hydrocarbon, C12H26, breaks down to produce C8H18 and C4H8. So this is what cracking is about. It could either be catalytic or it could be thermal cracking. So we are going to put D as the answer to this. So that is how to answer these questions. Of course, you need the knowledge of every form of symbol and equation that you've learned in chemistry. And that would help you to give answers to questions like this. All right, so read further to understand most of these equations. Now, let's go to the next series of questions. This is question 2. We are given the symbols of elements in period 2 of the periodic table, and we were expected to use these symbols to answer questions. Now, the first question says, which of them makes up approximately 78% of clean dry air? Now, this is from chemistry of the environment. When you look at the composition of air, you see that nitrogen has the largest composition of about 78%. So all we need to do is to write the symbol of nitrogen in this case. The next one says, which of them contains atoms with only 3 electrons in the outer shell? Now, for you to do this, you need the knowledge of the periodic table, and what you need to extract from the periodic table is the atomic number or the proton number of each of these elements. So when you have the proton number of this element, you use it to write the electronic configuration, and then you know which atom has 3 electrons in the outer shell. So for lithium, for example, if you consult the periodic table, it has atomic number 3, beryllium 4, boron 5, carbon 6, and we could go on like that. So if we begin with lithium, electronic configuration, the first shell can contain a maximum of 2 electrons. So we are left with one more, so it has 1 valence electron. If we do for beryllium, in this case, beryllium has a maximum of 2 in the first shell, and to balance it with the proton number, we add the second 2 in the second shell. So it has 2 valence electrons, or 2 electrons in the outer shell. But when we get to boron, of course, we do the same thing, 2 electrons in the first shell, and to balance it with the atomic number of boron, the next shell would have 3 electrons to make it up to 5. So we see that for this question, boron is the answer because it has 3 electrons in its outer shell. So all we need to do is to just write boron, B, the symbol of boron. Which of them contains atoms with only 9 protons? Now, the number of protons is simply the atomic number. So go to the periodic table as well. You check. You see that the element with atomic number 9 is simply fluorine. So 9. So because it has atomic number of 9, it means it has 9 protons. So all we need to do is to write F here, the symbol of fluorine. Which of them exists as graphite? Now, graphite is an allotrope of carbon. It's simply a form in which carbon can exist. Okay, we have diamond, we have graphite. So in this case, we look at the symbol of carbon and we place it here. Which of them is an alkali metal? Now, alkali metals are simply metals in group 1 of the periodic table. So if you go to consult the periodic table, look at the first vertical column there, you have all the alkali metals listed there, starting from lithium. So if you check there, you see that lithium is there. You also have sodium, potassium, but we do not have sodium and potassium in the options. So lithium will be the answer here. Which of them only has an oxidation number of 0? Now, for an element to have an oxidation number of 0, it means that such element do not donate electrons and they do not receive electrons. Now, what comes to your mind are the noble gases. The noble gases do not donate and they do not receive electrons. And from your options that we are giving, the only noble gas here is neon. So all we need to do is to include this here. So that is how simple this particular set of questions are. All right, now let's move to the next question. Boron has 2 isotopes. So state the meaning of the term isotopes. Okay, so isotopes are simply atoms of the same element. Okay, atoms of the same element with equal number of protons, with equal number of protons and different number of neutrons, and different number of neutrons. So neutrons. Now, isotopes, of course, will have the same number of protons, okay, but they have different mass numbers. So the differences in mass numbers is because they have different number of neutrons. Remember that the mass number is the number of protons plus neutrons. So when they have equal number of protons, what is responsible for the differences in mass number is the fact that the number of neutrons are different. So when you're asked to define isotopes, to get these 2 marks, you have to tell the examiner that the isotopes are simply atoms of the same element with equal number of protons. That is, their proton numbers are the same, but their mass numbers are different because they have different numbers of neutrons. So this will get you the 2 marks for this question. Okay, so I believe that's clear enough. Now, moving to the next question, we're given a table that shows the relative masses and percentage abundances of 2 isotopes. So we are expected to calculate the relative atomic mass to 1 decimal place. Now, this is a very easy question. Now, you should know that the relative atomic mass, I'll call it RAM, is equal to the percentage abundance of the first isotope, which is 20%, multiplied by the relative mass of the first isotope, which is 10, plus the percentage abundance of the second isotope, which is 80%, multiplied by the relative mass of the second isotope, which is 11. So if you use your calculator in this case, we do 200 divided by 100, that is about 2, plus we do 80 times 11 divided by 100, and that is 8.8. So if we add up these 2 numbers, we have 10.8, which is already in 1 decimal place. So this is the answer to this. So if you do this, you have 2 marks. Okay, so the next question is about ionic and covalent compounds. Right now, we are given 2 atoms here. We have sodium reacting with oxygen to form ionic compound, sodium oxide. Given the electronic configuration of sodium, because sodium has atomic number of 11, so because it has atomic number 11, the electronic configuration is about 2 electrons in the first shell, 8 electrons in the second shell, and 1 as the valence electron. For oxygen with atomic number 8, 2 electrons in the first shell, 6 electrons as the valence electrons. Okay, so that's the information we have here. So the ions are formed by the transfer of electrons. We're trying to establish here that the bond existing between these 2 is an ionic bond because the metal there transfers electrons to the non-metal, which is oxygen. So we're expected to complete the dot and cross diagrams in figure 3.2 to show the electronic configuration of 1 sodium ion and 1 oxide ion, show the charges on the ions. Now, you need to understand that when sodium, which happens to be donating 1 electron, bonds with oxygen, which from this case, you see that oxygen is in need of 2 electrons to achieve or to complete octet. That is to have a completely filled outer shell. It needs 2 more electrons. So it is simply 2 minus because it needs to receive 2 more electrons. Now, from your knowledge of formulas, generating chemical formulas. Okay, from your knowledge of chemical formulas, you need to realize that for the formulas to exist, there needs to be an exchange of charge, excluding the charge. It needs to be an exchange of the powers. Okay, so the 2 comes down here and the 1 here comes down here. So we're going to have a formula like Na2, okay, and then the 1 comes down to meet oxygen, so we have O. So what we're trying to establish here is that if sodium is to go into an electrovalent or ionic bond with oxygen, you are going to need about 2 sodium atoms to bond with oxygen. That is the first one goes to the first sodium will donate the first electron to this space, and then the second sodium will donate to this second space. So that needs to be understood first. Okay, so now let's go straight to drawing the cross and dot diagram. So of 1 sodium ion, okay, so we're going to go ahead to draw that of 1 sodium ion. Now the first one has been drawn for us. That is the first 2 electrons which are here. So we're going to draw the next one, which is the 8 electrons that should be in the outer shell. So we'll draw this. Then we have 1, 2, 3, 4, 5, 6, 7, and 8. So now we have sodium ion electronic configuration donating 1 electron. So because it's donating 1 electron, we just indicate that as plus. Let me write this properly so we can comprehend it. So it's plus. 1 electron has been donated. Now, the next thing is to draw that of 1 oxide ion. Now, the oxide ion that has been received, of course, it has, remember we said earlier that there are 2 spaces available. So we are going to see something like this. Okay, let's draw this well so that it doesn't look like okay, so we draw the circle properly, right? And then remember that we look at the previous diagram. There are 2 bonded electrons here. So the spaces are here and here. So because the sodium ion will be donating 1 electron each, so the first donation will take place here, and then the second one will equally take place here. So that is why we would have, since it's receiving 2, it becomes 2 minus. Okay, so this is what you're expected to do to get the full 2 marks. This is an ionic bond representation, and this would give us the formula that we had here. Okay, so the next question there says write the formula of sodium oxide. We've already written that as Na2O, and we explained why it is so already in the previous point. Okay, so moving forward, still we have a question on bonding. Carbon dioxide is a covalent bond. We are expected to complete the cross and dot diagram of this covalent compound. Now, looking at the electronic configuration of carbon with 6, so we are looking at 2, 4. And then oxygen, we wrote that already. You have 2, 6 as the configuration. So usually what you expect is for carbon, since it has 4 valence electrons, what you expect is something like this. 1, 2, 3, 4. Okay, and for oxygen, since we are only drawing the outer electrons, which is the 6, so we expect something like what we had before the previous question. So we have something like this, something like this. Okay, let's say something this and this. Okay, but if you're drawing something like this, then you're actually wrong, because this is not covalent bonding. Covalent bonding simply deals with the sharing of electrons where both atoms involved will contribute equally to that bond of covalency. So in this case, we need to restructure this. And how do we restructure this? Carbon has these extra electrons that would come in here to bond with the extra oxygen atoms that needs electron. So what we are going to do now is to restructure this to make it, to show how it's supposed to be a covalent bond. So all we need to do is to simply erase these points, erase this, erase this, erase this, and erase this. Okay, so the 2 bonded electrons already there for oxygen. So what happens in this case is that the carbon will donate, will contribute 1 here, and then the oxygen brings in the other. Okay, and then the carbon contributes the second one, and the oxygen brings in the other. And that's what's going to happen here as well. So this is how the covalent bond occurs in carbon dioxide. So this is what is expected. There is a mark for indicating this, and there's a mark for indicating this bonded electrons at the intersection. So please take note of this. All right, so moving forward, the melting points of sodium oxide and carbon dioxide are shown in table 3.1. Explain in terms of bonding why sodium oxide has a high melting point. So looking at the table, we see that sodium oxide has a very high melting point compared to carbon dioxide, and it has to do with the kind of bond. In sodium oxide, we established that it's ionic bond. In carbon dioxide, we understand that it is covalent bond. So in terms of bonding, to get the full 2 marks, we are expected to explain why sodium oxide has a high melting point. So for something to have a high melting point, that means it is due to the strong force of attraction. It is due to the strong force of attraction. Now, ionic bonds generally have higher melting points and boiling points. So it is due to the strong force of attraction between what? Sodium ion, the sodium, remember we established before, the sodium and the oxygen. So this is positive and negative. So it is due to the strong force of attraction between the positive ion, and the negative ion, So this is what resulted in the high melting point of sodium oxide. There is a strong force of attraction between the positive ion, that's sodium, and the negative ion, oxygen. Now, carbon dioxide has a low melting point. State the general term for the weak forces that cause carbon dioxide to have a low melting point. Now, those weak forces are simply called intermolecular forces. Intermolecular forces. And examples of the intermolecular forces are simply what we call the van der Waals or the hydrogen bond, dipole. So these are weak intermolecular forces that could cause a compound or a molecule to have a low melting point. All right, moving forward. Oxygen is produced by the decomposition of aqueous hydrogen peroxide. Manganese 4 oxide is a catalyst for this reaction. State the meaning of the term catalyst. These are quite easy questions, and there are just 2 points you need to state in questions like this. Now, a catalyst is a substance. Sorry, let me write it properly. So, a catalyst is a substance that increases the rate of a reaction. And remains, very important, and remains unchanged at the end of the reaction. So the 2 points that can get you your marks is the fact that you stated that a catalyst increases the rate of reaction. That's the first mark. And the second mark is the fact that you would mention that it remains unchanged at the end of the reaction. So that means at the end of the reaction, you can simply obtain your catalyst back and reuse it for any other reaction you want to use it for. That is the beauty of using catalyst. All right, so the next question says the student adds powdered manganese 4 oxide, and this is the diagram to show what happened. So the mass decreases as time increases. So aqueous hydrogen peroxide, and then this is the catalyst that was added. Then there's a loosely fitting cotton wool plug, okay, and then there is the balance to measure the mass. So state why the mass of the conical flask and its content decreases as time increases. So the content will likely decrease because something is actually giving off from these flask. Okay, and if you look at the reactant here, you see that this aqueous hydrogen peroxide is about H2O2. So that means a gas is likely giving us, and this gives us an idea that the gas is giving off because we have a loosely fitting cotton wool to allow the gas to go off. So why the mass of the conical flask and the content decreases is because oxygen gas is giving off. Oxygen gas is giving off. So as oxygen gas goes off, the mass decreases. The rate of reaction is highest at the start of the reaction. The rate decreases and eventually becomes 0. Explain why the rate of reaction is highest at the start of the reaction. Now, at the beginning of the reaction, the particles of the hydrogen peroxide are close together. Okay, and that is why the frequency of collision is really high. So in this case, what we need to write is that at the start of the reaction, at the start of the reaction, at the start of the reaction, the concentration of hydrogen peroxide, okay, the concentration of hydrogen peroxide is high. Okay, the concentration of hydrogen peroxide, that's H2O2, is high. Or you could say that at the start of the reaction, the particles of the hydrogen peroxide are closely packed. So when they are close like that, there is more collision occurring, and that is why the rate is fast. So at the start of the reaction, the frequency of collision is high. So any of them could give you the mark. So I would just stick with, at the start of the reaction, of course, the concentration of the hydrogen peroxide is high. So this will result in a higher rate of reaction. Now explain why the rate of reaction eventually becomes zero. The rate of reaction eventually becomes zero because the aqueous hydrogen peroxide is used up. That is the aqueous hydrogen peroxide. Okay, the aqueous, as the aqueous hydrogen peroxide is used up. So when the particles, when the is used up, what happens is there are fewer particles that collide, and therefore the rate becomes zero. Okay, so that is why the rate of reaction eventually becomes zero. The particles or the acid, the hydrogen peroxide, has been used up. All right, so I believe that is clear enough. Okay, so move to the next question. The experiment is repeated at an increased temperature. All other conditions stays the same. Explain it in terms of collision theory. Please take note of this. In terms of collision theory, while the rate of reaction is higher at an increased temperature. Now, in terms of collision theory, what you need to look at is, number one, the kinetic energy. You have to talk about the kinetic energy because you're looking at 3 marks here. And the frequency of collisions needs to be brought in. Frequency of collision. And then you also have to talk about the energy of the particles, okay, when compared to activation energy. So these are the 3 points we are going to bring in to answer this question. Okay, so explain in terms of collision theory why the rate of reaction is higher at an increased temperature. So at an increased temperature, what happens is that the kinetic energy of the particles increases. The kinetic energy of the particles increases, resulting in an increase in the frequency of collision. Resulting in an increase in the frequency of collisions, of the particles. Therefore, there is a higher fraction, there is a higher fraction of particles with energy. There's a higher fraction of particles with energy equal or greater than the activation energy. Please bear with the writing, but I believe the point is clear. Remember I said that when you are given a question like this, These are the 3 points that can get you the 3 marks. First, you need to talk about the kinetic energy of the particles. Talk about the frequency of collision, and then talk about the energy of the particles. That was why I begin that at an increased temperature, what happens is that the kinetic energy of the particles increases. And this results in an increase in the frequency of collisions of the particles. Therefore, there is a higher fraction of particles with energy equal or greater than the activation energy. Okay, and that is how to explain in terms of collision theory. Okay, I believe this explanation is clear. So for you to have these 3 marks, each of these points gets you 1 mark. So when you mention them, it gets you your 1 mark, and then you have a better result. All right, so moving forward, the equation for the composition of aqueous hydrogen peroxide is shown. All right, this is the equation of the decomposition. Then the parameters given are that 50 centimeter cube of 0.2 mole per dm cube solution of hydrogen peroxide is used. Calculate the mass of oxygen that forms. Now, for us to calculate the mass of oxygen that forms, we are asked to follow these steps. So, to calculate the number of moles of hydrogen peroxide used, okay, so in this question, we are given the volume of hydrogen peroxide to be 50.0 centimeter cube, and the concentration to be 0.2 mole per dm cube. Now, we look for a relationship that relates number of moles to all of this. Remember that we are looking for the number of moles. Now, recall that the concentration is not equal to the number of moles divided by the volume. This is the formula. So, forget the number of moles, the N becomes CV. Okay, concentration times volume. But you equally need to be careful because the concentration is in dm cube, but the volume is in cm cube. So we have to unify the unit. Let's convert the volume to dm cube. Remember that 1000 cm cube makes up 1 dm cube. So if we want to convert that, we're going to have 50 divided by 1000. So 50 divided by 1000 gives us 0.05. Okay, 0.05. So our N now becomes concentration is 0.2 times the volume that has been converted, which is 0.05. Okay, so if you multiply this, 0.2 multiplied by 0.05, the number of moles of the hydrogen peroxide is 0.01. Okay, 0.01. So when you have a question like this, be careful that the unit needs to be uniform. Now, the next question says determine the number of moles of oxygen produced. Now, we go back to the equation and use the stoichiometry to get the volume, to get the number of moles of oxygen produced. Now, stoichiometry is look at the coefficients of each of the compounds involved in this reaction. So, in this one, we have 2 moles reacting to produce 2 moles of water and then 1 mole of oxygen. Okay, so this is the stoichiometry. So what we are comparing now is hydrogen peroxide and oxygen gas. So that's about 2:1 in terms of hydrogen peroxide to oxygen gas. Okay, now remember that we just calculated the number of moles of hydrogen peroxide to be 0.01. This is 0.01. This is because remember this is for the hydrogen peroxide 2, so 2:1 for oxygen. So the number of moles of hydrogen peroxide is 0.01 in this, as far as the reaction is concerned. Now, 2:1 means 1 is simply half of 2. So for us to get the ratio of oxygen in this case, we are simply going to do half of this. So to get half of this, it becomes 0.01 divided by 2. So we do that, it becomes 0.005. So that what we have done is we are applying stoichiometry, looking at the ratios. So that means the amount of oxygen here becomes 0.005. Okay, now we have the number of moles of oxygen. So the next thing is to calculate the mass of oxygen produced. Now that we have the number of moles of oxygen, how do we get the mass? you have to look for a formula that relates the number of moles to the mass. And remember that the number of moles is the mass divided by the molar mass. Okay, so we have the number of moles of oxygen already. Can we obtain the molar mass of oxygen? Yes, we have the formula of oxygen. So if you go to consult the periodic table, you get the molar mass of oxygen. So molar mass of oxygen, which is O2, now becomes the 2 times 16 because oxygen mass is 16. So the molar mass of oxygen is 32. So if the molar mass of oxygen is 32, so the N will become, let's scroll up a bit, N becomes, okay, we are calculating for mass. So the mass is what we are calculating for. So the mass will be equal to the number of moles times the molar mass. So the molar mass is 32 and the number of moles is 0.005. So it becomes 0.005 times 32. So you press your calculator, we have 0.16. So that is the mass of oxygen produced. So what we have done is we've used the formulas to bring out the relationship between the entities we are trying to calculate for. That is very important. Now the next question says, state the effect on the mass of oxygen produced if the mass of powdered manganese 4 oxide catalyst is increased. Now, no matter the mass of a catalyst used, no effect, okay? The catalyst does not affect the quantity of the product, okay? So there is no change or there is no effect on the mass because the catalyst does not affect the quantity of the product. Oxygen can also be produced by the decomposition of mercury 2 oxide. Now, decomposition simply means the breakdown of mercury 2 oxide. The only product of this decomposition are mercury and oxygen. Write a symbol equation for this decomposition. So, if mercury 2 oxide breaks down, we're going to have mercury plus oxygen. So, this is the way oxygen is written. So, we have 2 oxygens here, so we need to put 2 here. There should be 2 here, and that balances the equation. Okay, so this is the answer to this question. Moving forward, the question is about electricity and chemical reactions. Okay, so the electrolysis of concentrated aqueous potassium bromide using graphite electrode forms hydrogen at the cathode and bromine at the anode. Okay, so when we are looking at potassium bromide, we are looking at KBr. So KBr has the hydrogen at the cathode, which the cathode is the negative electrode, and then bromine at the anode, which the anode is the positive electrode. So the electrolyte becomes aqueous potassium hydroxide. Okay, so state what is meant by the term electrolysis. 2 marks for this. So electrolysis is the breakdown. So electrolysis is the breakdown of an ionic compound in the molten or aqueous state due to the passage of electricity. So this is the definition that gets you the mark. For the fact that you mentioned that it's a breakdown of not just any kind of compound, but an ionic compound, gets you some mark. And then in the molten or aqueous state is equally important. Because if these ionic compounds are not in the molten or aqueous state, then it will be difficult to break down due to the passage of electricity. So take note of this point: breakdown of ionic compound in the molten or aqueous state due to the passage of electricity. And that should get you the full marks for the question. State why graphite is suitable for use as an electrode. Now, graphite is suitable because it is inert, that is, unreactive, and a good conductor of electricity. of electricity. So that is why graphite is used. It's unreactive, is inert, and then it's a good conductor of electricity. Write an ionic half equation for the formation of hydrogen at the cathode. Now, at the cathode, there is gaining of electrons. So the hydrogen ion gains electron to form the hydrogen gas. Okay, I always like including state symbols in this case. So to balance the equation, two hydrogens here, so there should be two here. And then to balance the charge, include a 2 here so that the 2 plus minus 2 becomes 0. So this will get you the full 2 marks. Name the type of particle responsible for the transfer of charge in the conducting wire. So the electrons are the type of particles. So the flow of electrons is what electricity is all about. Now, name the type of particle responsible for the transfer of charge in aqueous potassium bromide. Now, we're talking about the ions of the potassium bromide. So the ions are responsible in this case. Now, state the names of products formed when electricity is passed through dilute aqueous potassium bromide using graphite electrodes. Okay, so take note, dilute aqueous potassium bromide. Dilute means it contains a certain quantity of water. So we're looking at KBr, and then since we're looking at KBr and it's in aqueous form, so we break it down into the cations involved and the anions involved. So the cations involved are the positive ones here. We have the K plus and the H plus because it is aqueous. And for the anions, we have the Br minus and OH minus. So the reactivity comes into play here. So in this case, at the anode, we are looking at bromide ion and the hydroxide ion. Of course, the hydroxide ion goes to the anode and forms oxygen. So that is what is obtained at the anode. And then for the cathode, the reactivity comes into play as well. So hydrogen ion goes in there. So the cathode has hydrogen. So that's for that. Now, bauxite is an ore containing aluminium. Aluminium is extracted by electrolysis of purified bauxite in molten cryolite using carbon electrodes. So name the aluminium compound in purified bauxite. Purified bauxite is simply aluminium oxide. So aluminium oxide is the purified bauxite. So state 2 reasons why cryolite is used in this electrolysis. Number 1 is to lower, let's write this properly. So one of the reasons why cryolite is used is to lower the melting temperature of the bauxite, so that on the long run it reduces the cost. So to lower the melting temperature. And then secondly is to improve conductivity. Another point is it's also acting as a solvent, so that could also be included, but this is just 2 marks, so 2 points. Either of the two would get you marks. The anode is made from carbon. Explain why the carbon anode has to be replaced regularly. Now remember that in the electrolysis of the bauxite, the oxygen is produced at the anode. So when the oxygen is produced at the anode, it reacts with the carbon to produce carbon dioxide. So this is what is obtainable at the anode. Okay, and then this carbon dioxide goes off as a gas, and that is why there is a need to keep on replacing the anode, because this is a gas that is given off due to the production of oxygen that reacts with the carbon electrode to produce this. So to explain this, we say that the carbon electrode reacts with oxygen, carbon electrode reacts with oxygen at the anode, reacts with oxygen at the anode to yield carbon dioxide, to yield CO2. So it is this carbon dioxide as the gas that is giving off, and then there's a need for a replacement. Hydrogen-oxygen fuel cells can be used to produce electricity in vehicles. Write the symbol equation for the overall reaction in a hydrogen-oxygen fuel cell. So hydrogen-oxygen fuel cell, we're having H2 gas plus O2 gas to liberate water, H2O. So right, balance this. So this is the symbol equation for the overall reaction in the hydrogen-oxygen fuel cell. Now, state one advantage of using hydrogen-oxygen fuel cells instead of petrol in vehicle engines. Now, when you burn hydrocarbons, what is likely going to be produced is carbon dioxide and water. So when combustion of hydrocarbons completely would yield this, incomplete combustion would yield carbon monoxide and water. So one advantage of using hydrogen-oxygen fuel cell instead of these hydrocarbons is no carbon dioxide is produced. So no carbon dioxide is produced. So you don't have to contend with the problem of carbon dioxide. And remember that carbon dioxide is a greenhouse gas, which can result in climate changes and global warming. So in the case of using hydrogen oxygen fuel cell, we do not have a challenge with the production of carbon dioxide. So that is why it was one advantage of using hydrogen oxygen fuel cells. Another advantage is that the hydrogen oxygen fuel cells are very efficient. So they are efficient could also be a second reason why hydrogen oxygen fuel cells are more preferable than the petrol burning of hydrocarbons such as petrol. Okay, so question 6, we have the process. The question is about sulfur and compounds of sulfur. Sulfur is converted into sulfuric acid by the contact process. The steps or the stages are given, and then the first one says in stage 1, iron pyrite can be used instead of molten sulfur. So the iron pyrite is heated strongly in air, and we are expected to balance the equation. So in situations like this, we are going to balance oxygen as the last thing in this case. So two ions are on the right side, which is the product. So we can simply write 2 for now to balance it on the left. Sulfur, we have 2 sulfurs on the left, rather 2 times 2 here, that's 4 sulfurs. So on the right here, we have just 1, so we could write 4 sulfurs, okay, to balance the number of atoms of sulfur. Now we can talk about oxygen. So on the left now we have 3 oxygens plus 8 oxygens here, because 2 times 4 is 8, that's 11 oxygens. So if there are 11 oxygens here, okay, we have 8 oxygens here plus 3 oxygens here. So if there are 11 oxygens here, I could write 11 over 2 here. So 11 over 2 means the 2 here cancels out the 2 here and we have 11. So I will try and remove this fraction by multiplying by 2. So if I multiply everything by 2, I will have uniform whole numbers for everything. So I will use the eraser now. So if I multiply by 2, this place no longer becomes 2, but rather it becomes 2 times 2, which is 4. If I multiply by 2 here, of course this 2 goes off, and I'm left with just 11 here. If I multiply this place by 2, it just becomes 2 because there is nothing there before. If I multiply 4 by 2, it changes from 4 times 2 to 4 times 2, which is 8. So I believe this is the balanced equation for this. So let's confirm 4 ions on the left, 2 times 2, 4 ions on the right, 8 sulfurs, that's 4 times 2 for sulfur, 8 sulfurs on the right. 22 oxygens on the left, that's 11 times 2, and 6 plus 16 gives us 22 on the right. So that is how to balance the equation. Now the next question says, name this, include the oxidation number of iron. Now remember that for this formula to exist, that means there was an exchange of oxidation numbers. So this is Fe 3 plus, because the 3 here belongs to iron, all right, and then the 2 in iron belongs to oxygen, so every 2 minus. So in this case, I will simply call it iron, open a bracket. What's the oxidation number of iron? 3. So iron 3, and then I'll include the oxygen, which is oxide. So iron 3 oxide. That's as simple as it is. Now the equation for stage 2 is shown here. It's okay. The equation, the forward reaction is exothermic. That's a negative enthalpy. The reaction is carried out at a temperature of 450 degrees Celsius and a pressure of 2 atm. Using explanations that do not involve cost, explain why a temperature greater than 450 degrees is not used. Okay, why didn't we use a temperature greater than 450 degrees Celsius? So a temperature greater than 450 degrees Celsius was not used so that the yield, okay, so that it doesn't affect the yield of the SO3 that is produced. Okay, so the explanation is, let's write it properly. Okay, so why a temperature? Remember that this is an exothermic reaction, and because it's an exothermic reaction, okay, increase in temperature will simply move the equilibrium position to the left. So why the temperature greater than 450 degrees Celsius is not used is to increase the yield of SO3. That is to increase the yield of SO3. So that is why we do not use a temperature greater than 450 degrees. Explain why a pressure lower than 2 atm is not used. Now, remember that increase in pressure favors the side with lesser volume. Now, let's see the total number of volume on the left. So it is 2 plus 1 here. So there are 2 volumes here, 1 volume here. That's a total of 3 volumes. And on the right is just 2 volumes. So if you increase the temperature, if you increase the pressure rather, it will favor the side with lesser volume. That is, you have more yield of SO3. But if you reduce the pressure, you reduce the yield. Okay, so why a pressure lower than atm is not used is still the same reason that we have here, to increase the yield of SO3. So we use a pressure lower, a pressure of 2 atm, not a pressure lower, to increase the yield of SO3. Okay, now the next question: when sulfuric acid reacts with ammonia, the salt produces ammonium sulfate. Write the symbol equation for this reaction. So sulfuric acid is H2SO4 plus ammonia, which is NH3, to produce so in this case the ammonium sulfate, which is NH2SO4. It's the salt produced. So 2 nitrogens are in this case, so we have 2 nitrogens here. So I think that should be a balanced equation because there are 2 nitrogens, 8 hydrogens, 6 plus 2, 8, and then 1 sulfur, and then 4 oxygens, 4 oxygens. So this is what happens in this case. So in this reaction, what happens is that, of course, the acid donates a proton, and then this receives the proton that is donated by the acid, just like what we have on definition of an acid and a base or an alkali. So an acid is a proton donor. The base receives the proton and forms this. Okay, so next question. Lead 2 sulfate is an insoluble salt. Lead 2 sulfate can be made from aqueous ammonium sulfate using a precipitation reaction. Name a solution that can be added to aqueous ammonium sulfate to produce a precipitate of lead 2 sulfate. So we could use a soluble salt such as that contains lead. So we deal with lead 2 nitrates. So lead 2 nitrates, because all nitrate salts are soluble. So lead 2 nitrates could be a suitable option. Write an ionic equation for this precipitation reaction. Include state symbols. Now, when you ask to write an ionic equation for a precipitation reaction, your aim should be the salt that you are trying to produce, which is lead 2 sulfate. So lead 2 sulfate formula is PbSO4. So if you break this into ions, we have Pb2 plus, SO4 2 minus. So that becomes, the ionic form becomes Pb2 plus aqueous plus SO4 2 minus aqueous to form the salt, which is insoluble, PbSO4 and then solid. So this is what you should write and get the 3 marks. The precipitate of lead 2 sulfate forms in an aqueous solution. Describe how pure lead 2 sulfate can be obtained from the mixture. Now, when you are preparing an insoluble salt, heating is not required. Okay, because it's an insoluble salt. All right, so there's nothing to heat there. So in this case, you have mixed it says the pure lead 2 sulfate can be obtained from the mixture. How can we obtain this pure lead 2 sulfate from the mixture? So the first thing is, after mixing has occurred, filtration will take place. So we filter the mixture. Filter the mixture is step 1. Remember that there are 3 marks allocated. So the first mark is to filter the mixture. The second mark is, after filtering the mixture, is to wash with distilled water. Wash with distilled water or deionized water, as the case may be. And then the third mark will be to dry in an oven, in a warm oven, or to dry in between filter papers, as the case may be. So that will get you the full 3 marks. Okay, so we move to the last question in this series, which is about organic compounds. Okay, butane reacts with chlorine in a photochemical reaction, and this is the equation for the reaction. States the meaning of the term photochemical. So photo, from the word photo, light. Okay, so it's a reaction. Photochemical means in the presence of ultraviolet light. So in the presence of ultraviolet light. Okay, so any reaction that takes place in the presence of ultraviolet light, or light generally, is referred to as a photochemical reaction. Now, an organic compound with the formula C4H9Cl is formed when 1 molecule of butane reacts with 1 molecule of chlorine. Okay, that's more like a substitution reaction. So draw the displayed formula of the 2 possible structural isomers with the formula C4H9Cl. Now, a displayed formula shows the type of bond that are present. So let's begin with the first compound. Using this formula, 4 carbon atoms are involved. So showing the type of bond, 1, 2, 3, 4. Now, 9 hydrogens are attached to the first hydrogen up here, the second one right here, the third one right here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then chlorine is attached, so chlorine. So if I'm going to name this, I'm going to name this, since the chlorine is attached to the first carbon, so it's going to be 1 chloro. And what's the family? The parent is 1, 2, 3, 4. So 1 chlorobutane. So for me to draw a structural isomer of this, all I need to do is to change the position of the chlorine. The chlorine is on the first carbon in this case, so all I need to do is to change it to the second carbon, and then it becomes an isomer. Okay, because isomers are the same molecular formula but different structural formulas. So this is the second isomer. So it becomes H, H, H. Remember that the chlorine is going to be moved from the first carbon to the second, so I'll just put it here. And then every other thing will just have H. So we still have the 9 hydrogens attached. This and this. So I will name this now 2, because attached to the second carbon, counting from the right. So 2 chlorobutane. So this is what you're expected to do. Now you observe that I didn't count from this point, because if I count from this point, it becomes 1, 2, 3, 4. So it's not 4 chlorobutane, because the rules of naming is you have to give the lowest number. So I'll rather count from the right, because the right gives the lowest number. I think that should be clear enough. Now the structure of a compound is given like this. So this is the structure you're given. Deduce the molecular formula of compound A. So remember what molecular formulas are. They show the actual number of atoms in the molecule of the compound. So actual number is to count each atom that is present. So let's start with carbon. How many carbons are present here? 1, 2, 3, 4. So C4. Next thing is to count hydrogens. How many hydrogens are there? 1, 2, 3, 4. So 4 hydrogens. Are you sure we have 4 hydrogens? Let's go again. 1, 2, 3, okay, 4, 5, 6. So 6 hydrogens. So H6. Okay, now let's count the number of oxygen. So 1, 2, 3. So there are 3 oxygens. So O3. So let's go over it again. So how many carbons? 1, 2, 3, 4. 4 carbons. Okay, you're right with that. Then hydrogen. 1, 2, 3, 4, 5, 6. So 6 hydrogens. And the oxygen. 1, 2, 3. So that is the molecular formula, showing the actual number of atoms present. Now there are 3 functional groups in a compound. Name the homologous series of the compounds that contain the following functional groups. Now we know that the functional groups are simply what determines the chemical properties of these substances. So for C-double-bond-C, of course, you know the homologous series for this is alkene. For OH, the homologous series is the alcohol. And then for COOH, the homologous series is carboxylic acid. So the carboxylic acid will always have the COOH, the alcohol will always have the OH, and the alkenes will always have the C-double-bond-C. Now, state what is observed when compound A is added to aqueous bromine. So if you add compound A to aqueous bromine, remember aqueous bromine is used to differentiate between a saturated and a non-saturated hydrocarbon. Saturated hydrocarbons are those with single bonds, carbon-carbon single bonds, while unsaturated are those with carbon-carbon double bonds and carbon-carbon triple bonds. Now, because of this double bond present in this compound, by the time you add aqueous bromine, okay, it turns it colorless. So it turns colorless. I think it decolorizes the bromine water. Bromine water is brown. So when you add an unsaturated hydrocarbon or an unsaturated compound, it turns it colorless. So when you add aqueous sodium carbonate to this, of course, effervescence or fizzy sound will be expected. So effervescence observed. So when you observe, effervescence will be observed to show you that a gas is giving off. Okay, so the next question. Compound A can be used as a single monomer to produce 2 different polymers. Draw 1 repeat unit of the addition polymer formed from compound A. So if you look at compound A, remember that this is an alkene, which is now a monomer. So when it becomes a polymer, what happens is the double bond breaks. So we're going to have single bonds in this case. So the repeat unit is going to be something like this. So this double bond breaks into single bonds. And then we go back again to look at the functional groups attached. So COOH. So on top here we have COOH. And then we have H here. And then here we have, let's see, H and CH2OH. So H and then CH2OH. And then to show that it's a repeat unit, we had the bond. So this is what is expected in this question. All right, next question. Compound A can be converted into a dicarboxylic acid. Name the type of condensation polymer formed when a dicarboxylic acid and a diol. So a dicarboxylic acid and a diol. A diol is simply from an alcohol. So when this happens, of course, you know we are forming an ester, like we mentioned. When a carboxylic acid is reacting with an alcohol, an ester is formed. But in terms of condensation polymer, we are going to have a polyester. So a polyester is what is obtained. I think that's the end of this paper. So thank you once again for subscribing to this channel. And I hope you enjoyed the video and you learned a lot from it.
I want to talk about a very important YouTube channel called HR Tech. Trust me, this YouTube channel is a giveaway. It's loaded with IGCSE. Trust me, is a giveaway. This channel is helpful for your group studies, your personal studies, and it has a proven track record of producing excellent results. So do me a favor, click on the subscribe button, okay, and share this YouTube channel with your friend. Trust me, that will be the best gift that you are giving to them. Thank you very much, and I'll see you in my next video. Bye bye.